Today I'll talk about wearable sports and fitness technology, and hopefully you'll learn about some market trends and some system-on-chip technology trends. But before I get started, I wanted to thank everyone, or the country of Korea, for hosting the President's Cup, which is a very big professional, international golf tournament. And also, it's interesting that it's the first time that it was hosted in an Asian country, so this is a very big milestone. Golf is a good example of wearable technology. It's one of the first sports wearable devices that were out on the market. You know, it tells you, provides you with GPS information and range and elevation changes, so it's a good example of wearable sports technology and where we're going. So I'd just like to tell you what key topics we'll be covering today. The first is wearable sports technology market landscape, and that includes the market drivers, the different sports applications, and the different trends. And then I'll talk about system-on-chip technical trends for wearables. And I'll focus on two areas. One is compute SoC, the second is power SoC. And then I'll talk a little bit about the business ecosystem in terms of macro trends and collaboration that's needed in the ecosystem. And then we'll finish with a summary and a question and answer session. One key takeaway from our meeting today is that in the coming years, we can expect to see widespread adoption of wearable sports technology as a tool to promote healthy lifestyle. And that's really what's going to make wearable technology become a big market, is when the users get meaningful results from their wearable device. So this is our outline for today. We'll cover market drivers, applications, the market and applications trends, compute SoC. So this will be able to help us keep track on the topic that we're discussing. The first is market drivers. So really there are three trends driving the market. One is segment advocates, second is social impact, and the third is consumer interest. They're driving interest in sports and fitness, which in turn is driving interest in sport wearable devices. So first I'll talk about segment advocates. So the first group of segment advocates are the individuals, people like you and I, and the mobile generation, a demographic that's between the ages of 18 and 54, who make up 77% of all wearable device users. The second is our regional advocates. Every country around the world has a regional advocate. In the United States, it's, for example, the First Lady, Michelle Obama. She launched a campaign called Let's Move, which promotes exercise and activity for young people. And the third is our global advocates. For example, the United Nations has a campaign called Millennium Development Goals, which is championed by Ban Ki-moon, the United Nations Secretary General, and the purpose is to promote sports and fitness on a global basis. So together these forces come together and they promote sports and the benefits of sports and fitness, which has a social impact on everyone. So now we can talk about the social impact. The social impact is that there are benefits of sports and fitness. The first is quality of life. It's been shown that regular exercise builds resistance to some diseases. Also, team sports promote leadership and teamwork skills. And physical fitness promotes self-esteem and self-confidence, which leads to better mental health. The second benefit is an economic benefit. In the United States, the sports industry employs about 1.5 million people, which is about 1% of the gross domestic product. 1% of the United States payroll. In terms of revenue, sports is about a $700 billion business in 2014 worldwide. And in 2020, we expect wearable sports equipment to contribute $10 billion to the economy, growing at a compounded annual growth rate of about 103%. And the third is wellness. One example is safety and injury prevention, which I'll show you an example later. The other is conditioning and performance, where it's been shown that users of wearables rely on their wearable to promote regular exercise. So people who use wearables, they're reminded every day that they have to exercise, and they're immediately given feedback on how they're doing in terms of their performance level. So the third market driver is consumer interest. So a recent survey has showed that in the United States and Europe, the highest interest for sensor-based wearables is for the wrist. The second highest interest level is in embedded clothing. So the consumer interest level is driving the wearable sports technology market. So now I'll just briefly cover some applications. There are basically three types of sports and fitness application. One is wristbands, the other is sensor embedded equipment. You can see the sensors embedded in the equipment here, and smart clothing. And I'll talk about the technologies used in smart clothing. I think we're all familiar with the first application of wristband devices, very common. For sports watches, they're used for golfing, running, swimming, very popular. And then fitness, people are using them for activity trackers to keep track of calories burned, steps counted. The second application example is embedded equipment. For contact sports like American football, ice hockey, or equestrian, awareness of head injury is very important. And there are examples of equipment now on the market that embed sensors, impact sensors in the helmet to alert coaches of a potential head injury. So we call it injury analysis. And then, of course, there are many examples of sensors embedded in equipment, like a soccer ball and golf clubs, and the purpose is to act as a training aid to improve a player's performance. And the third is smart clothing. There are basically two popular technologies that are being used for smart clothing. One is woven, and the other is printed. Woven weaves conductive fibers within the garment that transmits and receives information from the sensors to a SoC. Printed technology prints using electronic ink into a garment, both sensors and conductors, and that connects it to an SoC. So examples are a smart shirt and a fitness shirt. So let me just quickly summarize some market and application trends. First, wristband devices will become much more powerful. The number of sensors or sensor density per device will increase on an average 3 times from what it is today. Also, we'll see integration of different communication technologies like near-field communications, NFC, be used as access control or mobile payment. Imagine you go out in the morning for a run. After you finish running, you want to buy a bottle of water. You don't have to carry your wallet or your smartphone. You can do mobile payment on your sports band. And then when you go back to work, you don't have your access badge. You can use your smart band to gain access to your office. The second trend will be equipment embedded fitness or equipment embedded sensors and edge analytics. Sorry about that. And the benefits of this will be used for movement tracking and performance data, as well as head trauma and injury awareness. And the big change is edge analytics, which means more of the data analysis will be done at the edge of the network as opposed to some remote cloud server node, which means access to data will be much faster and more relevant to the user. And the third trend we'll see is smart clothing with textile engineering. This will enable integration of more sensors into garments, and which will allow us to quantify ourselves. We'll understand better our physiological and environmental conditions. But the catalyst for all these trends is innovation in system-on-chip, and that's what we'll speak about next. So now we'll talk about compute SoC trends. Just to orient everyone, this is a typical block diagram of a wearable device. On the outside there's a power SoC, connectivity either through Bluetooth Low Energy or NFC or GPS. Then there's an array of sensors, inertial, temperature, heart rate, and light. And then there's a human interface, whether it's a display, a keypad, or audio. And then over here is your energy source. And right now we'll talk about at the heart of every wearable is the MCU SoC. So the first trend with MCUs is related to memory. First, there's going to be a requirement for more memory capacity. And this is driven by an increase in number of sensors. Earlier I mentioned that there's going to be a 3x number of sensors versus today. And basically that equates to about 4.1 sensors per device. The other is embedded algorithms and mobile applications on a wearable device, which requires more memory. And embedded algorithms are typically used to improve sensor performance and deliver some meaningful information to a user. The second trend is power efficient memory access. Obviously, because you have more memory, you need designers will need efficient ways to access the memory. So this means a peripheral management unit will be resident on the main MCU, which is a dedicated state machine used to offload the processor core and service memory and peripherals. The second big trend will be security. As wearable devices converge with the Internet of Things, they will be vulnerable to security attacks. The other is secure authentication, and this prevents device cloning as well as counterfeit protection. And the third is multiple layers of security or advanced security features will be needed. That includes cryptography and physical security, and a trust protection unit with encryption. These are the hardware blocks in an MCU needed to deliver multiple layers of security. There's instant memory erase, random number generator, pseudo-random number generator, tamper protection, unique identification, CRC generator, and AES engine. Together, these all deliver what Maxim calls a trust protection unit. And you'll see that in our new MCU. This is an example of the three of those trends being integrated into a Maxim device, the Max 32621, which is our ultra-low power MCU. There's a 8x increase in memory capacity from our previous generation. We have 2 meg of flash, 256K of SRAM, and 8x8 cache. And then there's a unique peripheral management unit that addresses memory access, which lowers power of the device by 30%. And then we have a trust protection unit to address security, which includes the hardware blocks that I just described. Next I'll cover power SoC trends. Again, just to familiarize you, same block diagram we talked about earlier, and this is the power SoC. Interfaces with the battery, provides all the power to the subsystem, and also provides fuel gauging. So before I get into it, I think an important thing to understand is the operating profile of a wearable device and how it differs from a smartphone. A wearable device spends a lot of its time in standby mode and occasionally wakes up to do sensing and then communicate with the edge. Basically what this means is, in terms of battery consumption, standby mode consumes about 25% of the battery power. The other 50% is sensing and 25% communications. So I'll explain why that's important in the next few slides. I'll just go over the power trends. As I mentioned, ultra-low standby current will be important because 25% of the battery consumption is in standby mode. That means the microcontroller, the power SoC, all need to have very low quiescent current or very low static current. The second trend is load-optimized DC power regulators. As I mentioned, 75% of the battery consumption is when the wearable device is either sensing the surroundings or communicating with the network. And the third trend is smart battery management. A power SoC will need to embed a very high accuracy fuel gauge algorithm to optimize the battery operating time, and also a smart charger that can manage the power source for fast charging. And I guess to summarize, the reason these trends are important is because users want their wearable device to operate for the longest amount of time without having to recharge it. And when they do have to recharge it, they want to be able to charge it fast. So now we'll show how Maxim is addressing those three trends. This is the MAX 14676, our PMIC for wearables. We have an embedded fuel gauge, which uses Maxim's proprietary model gauge algorithm. We have a smart battery charger, so that the device could charge from a USB port or another higher voltage power source up to 28 volts. And we integrate multiple very efficient, low quiescent current power regulators so that maximum efficiency in DC to DC conversion is achieved. Okay, so now we can talk about business ecosystem. Just to give you an idea of what's happening in the world, I think we're aware of some of this. You know, we started out with cloud computing, with servers in the cloud. And next we're seeing the Internet of Things. After that, we'll have big data, because the Internet of billions of connected devices in the Internet of Things will deliver a lot of important data. And then from big data, sports and fitness will evolve into what's called digital fitness, where big data will deliver meaningful results to help people live a healthier and better lifestyle. But to enable digital fitness, you need to have a business ecosystem. So let me just look, now we'll look at the ecosystem elements. First, there are cloud partners. Second, there's analytics, which is derived from big data. There's sensing at the at the wearable device of either physiological parameters or local environment. Then there's compute SoC on the wearable device. We need connectivity up to the cloud, and sometimes we need control of some element. So in order to realize the next generation of wearable sports and fitness devices that are useful, we'll need collaboration between all these ecosystem elements. One company cannot do it all. So we'll have to have coordination between the analytics, the cloud, the wearable sensing, and the network. A good example of this is Maxim just released the MAX 32620 Embed Development Board. And if you look at it, it's basically a partnership between Maxim, ARM, cloud partners, and it basically takes this whole ecosystem together to allow our customers to develop some IoT platform, which could be a wearable sports or fitness device, and manage all these different elements easily. And just to summarize what the business ecosystem looks like, this is Maxim, SoC development, but then we have mobile apps developers. We have wellness programs at our work or at our doctor's office. We have OEM product development companies. I don't have to mention the names, but you know all the big ones. And then we also have professional groups like the IEEE and the ISOCC, which is International System-on-Chip Conference. It's a subgroup of the IEEE, and just for a note, I just presented there earlier this week on a similar topic. And then you also have personal coaches and trainers. And then there are are businesses that provide sensor intellectual property, developers that specialize in really improving sensor performance and have algorithms that are valuable. And then, of course, there are data analytics developers. So partnerships with all these members of the ecosystem are very important. This is a good place to illustrate why security is important for wearables. So you can have an OEM product developer who licenses intellectual property from a sensor IP company, and in that wearable device, that proprietary algorithm needs to be protected for two reasons. One is the sensor IP provider wants to make sure their licensing agreement is met with the OEM, and the second reason is the OEM wants to make sure the algorithm is protected so that his competitor does not take advantage of it. So security is critical for wearable devices, and one example is intellectual property protection. And just the last thing about security, this is where Maxim is involved and where we help our customers. We're protecting the security of the intellectual property for the sensor IP developer and the OEM with security features in our MCU. So just to summarize the ecosystem trends, we'll see much more business collaboration and partnerships. One example is mobile apps developers, they enrich the user experience. The easier it is for a person to use their wearable device, the more valuable that device is, and that's really what mobile apps development provides. And intellectual property, for example, for sensors, can improve system performance, which gives the user much better and accurate information regarding their physiological condition. And coordination between all the apps, all the ecosystem partners will bring products to market much faster rather than having one company try to develop every single element within the ecosystem. So partnerships will be critical. And the second major trend is really more industry participation at conferences and events. For example, the IEEE, the ISOC, where people can share their thought leadership concepts, develop potential partnerships, and develop potential business relationships, and share knowledge related to system-on-chip technology. So I think what we can say is that we'll see widespread adoption of wearables because of several reasons. One is that exercise promotes health, social, and mental wellness. We know that. And we know that wearable devices encourage people or users to participate in either regular exercise and fitness. And we know there are benefits from the quantified whole body. In other words, understanding more about our physiological condition will help us live healthier, happier lives. And behind all that is SoC advancements. They're the catalyst. Without MCU and power management advancements and sensor advancements, we can't realize the next generation of wearable devices. I think the final summary is that we really need to observe low power methodologies and multi-layer security, and this is really where Maxim's focusing its efforts for the wearable sports and fitness technology market segment. Well, thank you, and I think we can have some question and answer.